topic of solutions, and we're looking at concentration. Now, the specific concentration that we're looking at today, guys, is called molarity. The nice thing about molarity, it's based on something that we discussed before in Chemistry 1, right? When we do stoichiometry, it deals with moles, folks, okay? And specifically, when you look on table T, right, you're going to see that molarity, big M, right? You guys can see a bit better. Molarity, big M, is a number of moles of solute over the liters of solution. Okay, let me change that to solution. Okay, man, no problem. Now, guys, you gotta know what's a solute and what's your solvent. Okay, what a solution means and so on. Right? We did all this already. Okay, leading into the introduction of solutions. Yes. So if you're iffy on that, please recap that. No problem. Okay, because sometimes the problem states what's a solute and what's a solvent or what's a solution, and sometimes it doesn't. It gives you the numbers and expects you to know what's what. Okay. So please be careful with that. Okay, no problem. All right, so moving on. You have a problem here to look into. All right, nice simple problem. It says to determine the molarity of 500 mLs of a solution with 0.4 moles of dissolved solute. Okay, so you got two things in play right here. You got 500 mLs, right? Now we said before that you must use what in the molarity calculations? You got to use liters of solution, people. So if they give you milliliters, we're not going to panic because we know how to convert milliliters to liters, right? Okay. And they gave us the moles already, okay, of solute, moles of solute, so we're happy. So we realize, right, since we're trying to find molarity, it's going to be moles of solute, okay, which is 0.4, okay, over the liters of solution. We just so happen not to have, okay, the liters, but we can convert it, right? No problem. So there's a number of ways you can do it. Divide by 1,000, okay, that's one, or move the decimal 3 places to the left, guys, okay? So let's do the decimal 3 places to the left. So once again, divided by 1,000 and moving the decimal 3 places to the left, same thing, okay? So when we move the decimal 1, 2, 3 places to the left, we're going to get 0.5 liters. Now, guys, always use what the formula asks for. If it asks for liters solution, don't try to force milliliters in there, okay? You'll mess up, you'll get it wrong, okay? If it asks you for moles, use moles, okay? Don't use anything else, okay? So that's what we're going to do, alrighty? All right, so we established, right? The moles of the solid goes on top. You put 0.4 moles on top right there, okay? And we're going to divide that by what? Not the 500 mLs, but by 0.5 liters, okay? Alrighty. So once again, convert your, if they're giving you mLs, use liters, convert to liters, okay? And you must work with moles. If they give you grams, you got to change to moles. They were so nice to give us moles this time, so no problem. We put our moles there, we're good to go. But we had to change our mLs to liters, so make sure you make a note of that, guys. Okay, so we know from experience, right, that when you divide by 0.5 or a half, it's the same thing as doubling the number, right? So we're going to get what? We're going to get 0.80 big M molarity, okay? Big M is the same thing as moles over liters, folks. And that helps when we're doing other problems, when we do our calculations, okay? Big M, moles over liters, means the same thing. But this big M is a shorthand way of representing moles per liter of solution, okay? Bam, and you're done. All right, next problem. Now, guys, please make sure, right, that you have your calculator and your reference table. So I'm looking around to find mine. Let me get my reference table, calculator. So I must have this handy. All right. So let's read this problem right here. So a 200 ml sample of solution, right, contains 8 grams of NaOH. What is the molarity? Now notice, right, they did not give us liters, but we're not going to panic. We're going to convert that to liters, right? No problem. Okay, now I'm looking in the problem, right? I know from the triangle that once again, right, draw a triangle again. That big M is what? Number of moles of solute, okay, over liters of solution, right? Using shorthand again. I don't see moles anywhere in this problem, but I'm not going to panic because I remember in stoichiometry, I can change what? I can change grams into moles, all right? So we have to do two conversions here. We got to change our mLs into liters, that's one. And the other conversion, we got to change our grams into moles. Now, if you remember, right, there's a formula on the back of your reference table called the mole calculation formula that helps you change grams into moles, guys, okay? So check that out. That's why you need a reference table handy, all right? No problem. So let's do first things first. So let's write this down. Big M, right, is equal to what? Is equal to moles, okay? You have it here already, right? And we don't have the moles, okay? So we're gonna wait a bit, we're gonna put it in. So let's right here, moles per liters of solution. So we have to make a note of that. All right, so our liters of solution will be what? Okay, that's gonna be moles, right? Over 3 places to the left, 0.2, right? Okay, but we don't know our moles just yet, but we're not gonna panic, okay? We're gonna put our moles in there in a second. So we got 0.2 liters, okay? So our liter solution is good, but now we have what? 8 grams of NaOH. Now remember this mole calculation formula, guys? Okay, that to find the moles, right, is going to be what? The given mass over the what, folks? Over the GFM. Okay, so it's given mass over GFM. That's also on table T, people. Okay, so what are we trying to find? We're trying to find the moles. We don't quite know the moles, right? Okay. But did they give us a mass? Yes, they did. 8 grams, okay? So we'll make a note of that. We have 8.0 grams of NaOH as our given mass. And we need to divide that by the GFM. Now, can you remember what the GFM is? Gram formula mass, yes? Okay. How do we find that? We add up the masses of each of these guys in the compound right here, right? So let's do it someplace where you have some space. Okay. Let's squeeze it in. Okay. So we have Na. Okay, you have one of them, and from my memory banks, Na is about 23, right? Okay, we have O, oxygen, you got one of them, and that's 16, okay? And we have H, right? And that's one of them, and that's 1. Now guys, once again, you keep working with these guys in reference table, sometimes the numbers stick in your memory banks, no problem, right? But if you can't remember the masses of these guys right here, don't panic. Just look at your reference periodic table and get the masses, no problem. So we got 1 times 23 is what? 23. Okay. 1 times 16 is 16. All right. And 1 times 1 is 1. We're gonna add those guys up to get our GFM, people. All right. So if I'm not mistaken, we got 0 right there. 1 plus 6 is 7. 7 plus 3 is 10. And carry the 1. That's gonna give us 40 grams per mole. That's our GFM. So our GFM is what? Is 40 grams per mole. Okay, so let me write this right there so you guys can see. So what do we have to do now? We have H, right? Divided by 40. Okay? Alrighty. I should be able to do that in my head, but my age is catching up with me. So 8 divided by 40 equals to 0.2 moles, okay? Bam. All right, so we have now our moles, people. So what do we have? We now have 0.2 moles of NaOH divided by 0.2 liters, all right? And I think I can do that calculation. That's gonna give us 1 big M, 1 molar, okay? In terms of the concentration, and you're done. So once again, guys, if you're given milliliters, change it to liters. This time here, they gave us the grams, they didn't give us the moles, but don't panic. We know the mole calculation formula from table T. Keep saying it over and over again. Chemistry is foundational, right? We did stoichiometry before, but it's still in effect, right? Because now we have to apply those concepts that we learned before in problems like this and so on, okay? So always review. All right, so the last problem right here. Just get that, bam. This problem is saying, right, how many grams, we're good for grams, of Mgso4 are dissolved in 80 mLs of a 0.75 big M solution. Now here's the deal, guys. Read the problem slowly, okay? So you read it slowly again. How many grams, okay? So you don't panic. Now you know from experience, right, that the mole calculation formula, it does not have grams in it, okay? So the molarity, calculate molarity. So molarity is what? Molarity is big M. The molarity formula is big M. Okay, molarity is what? Number of moles of solids. All right, okay, over liters of solution, right? Now the funny thing is there any grams here? No, there's not, right? But we're not going to panic, but we're going to realize something. That we can convert what to grams? We can convert moles to grams. So we realize, right, that if we find the moles, okay, then we can use the mole calculation formula and then find the grams. Okay, so that's what we're going to do. So what we're going to do is step by step. We're going to find the moles first, yes, okay, and then we're going to find the grams. But the question now is, right, how do you find moles? So look at the formula. Moles is our question mark, right? This guy right here is our X. We don't know what it is, right? But the triangle is telling us that we have to multiply these two guys. Big M times liters gives us moles, okay? And we're going to continue reading the problem. So, we have 80.0 milliliters. Now, we're not going to panic. That's milliliters, right? We can change that to liters, no problem, right? And we're given the big M right here is 0.75. So we have to multiply big M times liters to get our moles, and then we're going to change the moles into grams, and we're good to go. So let's go slowly. We got 80 right here, right, of ml. Okay, so what we're going to do, we're going to change that to liters. We're going to move the decimal point how many places? 3 places to the what? 3 places to the left. All right, so moving it 3 places to the left, we are going to get what? 0.08, okay, liters, okay? Are you guys with me? 0.08 liters. When we move it 1, 2, 3 places to the left, we need that guy, no problem. So that's our liters of solution. Now they gave us big M here, guys, at 0.75 big M. Now remember what we said before, right? Big M units, the units of big M is the same thing as what? 0 is the same thing as moles over liters. Okay, moles per liter is the same thing as big M. So when we're multiplying these two guys right here, the liters and the liters will do what? They will cancel out, guys, okay? So when the liters and liters cancel out, all you're going to do is multiply 0.75 moles by 0.08. So let's do that. Okay, 0.08 times 0.75, okay, equals 0.06. Okay, I'll trust that answer. So that's 0.06 moles, okay? So now we have our moles, all right? Now we know how to convert what? We know how to convert moles into grams, yes? Using the mole calculation formula. So let's set that up. Okay. Alrighty. So we have our triangle right here. I'm doing the mole calculation, and once again it's found on table T. Now, to find the moles, then it's going to be what? The given mass, okay, over the what? Over the Gfm. So what do we got to do now? We got to find the Gfm of Mgso4, okay? So let's do that, okay? So Mg, right, S and O, yes? We have 1 Mg, we have 1 S, and we have 4 oxygens, all right? So Mg, magnesium, right? I kind of can't remember its mass top of my head, so no shame. I'm going to take a peek on the reference table. It's, oh goodness, I need my glasses. It's 24.3, if I'm not mistaken, 24.3. Okay, 24.3. Alrighty. Okay, sulfur, S is 32. Okay, alrighty, 32. And O's are 16. Okay, alright. 16.0. So that's what, 24.3. That's 32. And 4 times 16 is 64. There. Alright, so we're going to add those guys up, and that's going to give us our GFM. Alright? Okay. So that's 0.3 there. Alright? 4 plus 4 is 8. 2, 10, carry the 1. Okay, 7, 10, 12. Okay? So that's 120.3 if I'm not mistaken. Okay, so 120.3 is our GFM. Okay? No problem. So what are we going to do with that value? We are going to use that value to find the mass. Now, if you look carefully as we're winding down, the moles here, right, times the GFM here, gives us the mass that we're looking for in the problem, right? We already have the moles here, guys. Right here is 0.6. That's our moles, yes? So we're going to multiply that 0.6 moles times the GFM. Now, remember the units of the GFM. It's what? It's 120 is the number, right? But the units of GFM is grams per what? Grams per mole, okay? So that's why units are important, all right? So we see the moles and the moles do what? The moles and the moles cancel out, okay? Leaving us with 0.06 times 120.3, all right? And that's our final answer. So let's check what that is. Okay, bam. Okay, 0.06 times 120.3. That equals to 7.22 approximately. Okay? Alrighty, so I'll put it at 7.22. 7.2. I'll put it at 7.2. Alright? Now, I'm not using sig fig rules, guys. Okay, so don't write it. Alright, so 7.2 grams of what? Of Mgso4. Final answer, you're done. Alright, guys, this is a few simple molarity problems. They're not that bad. Read the questions carefully. Make sure your volumes of solution is in liters. Make sure you got moles for your solids. Moles of liters is molarity. Always, guys, hard work plus sacrifice equals success. Take care, do well. All right?